Hello guys, here goes the first problem from the chapter work per energy. It says a locomotive of mass m starts moving so that its velocity varies according to the law v equal to a under root s, where a is a constant and s is a distance covered. Okay, find the total work performed by all the forces which are acting on the locomotive during the first t seconds after the beginning of motion. So they have not directly given anything related to force or displacement, but they expect us to find out the work performed. So Lakshman, how do you think these kind of problems should be solved in the exam?
Yeah, Naveen, hi. Let us go into the solution.
Yeah.
So in the given question, what it is given is finding the work done by the locomotive.
Yeah.
We know by definition of work is equal to integral f bar dot
ds bar.
And in the given question, as it's not the definite thing how much distance it has traveled and everything is that directly we can take off the vectors and we can write integral f bar f dot ds.
Okay.
And in the given, according to the given question, locomotive's mass is m, and let the acceleration of the locomotive be a
Okay.
into and ds.
Let that a be a of locomotive. Can you
Yeah.
please write it as al?
Yeah.
So that it
Okay.
avoids
Let it
confusion.
be al.
Okay.
So in this question, we don't know al and ds.
Okay.
So what we will do is by the given law.
Yeah.
What the given law is, v is equal to a under root s.
Okay.
So for according to definition of acceleration, what is acceleration? A l is equal to dv by dt.
Yeah, perfect.
dv by dt. So we will be differentiating the above equation, this equation,
With respect to time.
with respect to time.
Yeah.
So as a is constant, when we differentiate it with respect to t,
Yeah.
nothing happens. So
Yeah.
directly we
Yeah.
differentiate only s. What this gives us is a into 1 by 2 under root s into
Yeah.
dt.
Into
Sorry.
Okay. Into ds.
Into
By
ds by dt.
Yeah.
Yes. So al is equal to a by 2 under root s
Into v.
ds by dt.
Okay.
So now in this equation we don't know what is ds by dt.
Okay.
So for this what we will be doing is like we know v is equal to ds by dt.
Yeah.
So ds by dt is equal
So
to
Lakshman,
a under root.
I
Yes.
have a doubt here. Why can't we substitute a root s directly here
Where
in this equation? Because ds by dt physically means v, velocity.
yes.
And we have the equation for velocity as a under root s.
Yes.
So why can't we substitute that directly here in the equation?
in this equation you want to substitute
Yeah.
v is equal to a root s,
Yeah,
right?
I directly want to substitute a
Yes.
root s in place of ds
Yes,
by
yes.
dt.
Actually, we can do that. So,
Okay.
a by 2 under root s into ds by dt is actually v.
Yeah.
That is a into under root s.
Yeah.
S gets cancelled, and this will be equal to a square by 2.
Yeah,
A square by 2.
yeah.
So now the acceleration of the locomotive is a square,
by 2. Yeah, perfect.
So now going to this equation, why we are
Why?
doing actually this ds by dt is in work, finding the work done, we have a term ds.
Okay,
To
ds.
in order to find that, we are doing ds by
Okay,
dt,
fine, fine.
and from that we will be getting the s and t as the separate terms.
Okay,
no,
fine.
so now we can write this equation as ds by a under root s
Yeah.
is equal to dt.
Yeah.
So as let us consider it has traveled a distance s in time t.
Yeah,
So
yeah.
this is a definite integral.
Yeah.
So now integrating this from
Limits,
0
yeah.
to s ds by a under root
S.
s
Yeah.
is equal to
Integral.
actually
Okay.
when the a goes that side, here a will not be there.
Okay.
So this will at the same time this is equal to 0 to t as it traveled from distance 0 to time t
Yeah.
is equal to a into t, as a is
it
constant.
A into t or a into dt?
A into
I
dt.
think-
Yes,
yeah, yeah.
a into dt.
Okay.
As a is constant, it will be coming out,
Yeah.
and in the next step we can directly get this as 2 into
Yeah.
under root
S.
s is equal to
Yeah.
at.
Yeah, yeah.
Yeah, and here
So-
it is that will be equal to S is equal to
A
A
square.
square T square by
Yeah,
4.
perfect.
So now for getting ds, what we'll be doing is ds is equal to 2t dt into a square by 4. As this
Okay.
is
Yeah,
as
yeah.
this term is constant, it won't be changing.
Getting it.
So ds is equal to a square t dt by
Okay.
2.
Okay.
Now substituting this ds is equal to a square t dt by 2 and al is equal to a square by 2 in the work in the work
Yeah.
equation, what we got here, this will be getting integral m into a square by 2,
By 2
into
a square by 2 t dt.
dt.
Okay.
Yes. So now integrating this, we will be first we will generally just summarize this.
Yeah.
M into a power 4 by 4
Yeah.
into
t dt.
t dt.
Yeah.
So now integrating this from 0 to t,
Yeah.
as the locomotive traveled from the distance for the time 0
yeah.
to t,
Yeah.
we will be just integrating from 0 to t.
Yeah.
M into a power 4 by 4 into t dt.
Yeah.
So after integrating and solving just by this, we will be getting this as m a power 4 t
T
square
square
by
by
8.
Yeah.
So now work done by the locomotive in time 0 to t with the law V is equal to a under root s is m a power 4 by 8 into t square.
Yeah. So guys, what you can see in this problem is any problem starts from the very basic equation. So you should not worry that the data is not very related to the problem. You need to start from the very basic equation and then try to go into the sub problems like finding out the value of ds or finding out the value of al. And during integration, please take care of the limits. And one more thing, one very important thing to note is in the question it clearly states that what is the work done during the first t seconds. So you have to try to get everything in terms of the parameter time. So that is what has been done in the question, and you got the work as a function of time. Okay, let's move on to next question. Okay, let's get with the second problem on work. This is one of the very typical problems in which is asked in many of the competitive exams, and I feel that you should be thorough with these kind of models, and which gives the force as a vector, and it says that the particle moves along a path, and it asks us to find out the work done by the force in moving the particle along that path. Okay, let's go to the question. The work done on a particle of mass m by a force k into x by x square plus y square whole power 3 by 2 I cap plus y by x square plus y square whole power 3 by 2 j cap when a particle is taken from point a comma 0 to point 0 comma a along a circular path of radius a about the origin and xy plane. Okay Lakshman, so what do you think? How should we solve these problems? Is there some general tip or any general method to approach these kind of problems?
Yeah, Naveen, basically in these sort of problems they will be giving how the force vector is moving and how the distance vector is there, and in the given question what the force vector is given as
Okay.
f bar is equal to k into x by x square plus y square 3 by 2 I cap
Yeah.
plus y by x square plus y square whole power 3 by 2 into j cap.
Yeah.
And in the given question how the particle is moving, first we should analyze that.
Yeah.
What it is given is it is moving in a circular
Path. Yeah.
So first we draw a circle, and the initial position of the particle is a comma 0, and
Yeah.
let the center of
Center.
the circle be origin.
Okay.
So this position will be a comma 0,
Okay.
and it has moved to the point 0 comma a,
Okay.
and in the given question the radius is
A, fine.
so the perpendicular thing will be 0 comma a.
Okay.
So at any let us assume at some instance
Okay.
of the particle, let the particle be here after a time t, and we know this is r bar,
Yeah.
and the instantaneous distance of the particle direction will be in this direction,
Perpendicular to that. Yeah, yeah.
perpendicular to the r bar,
Yeah.
and this is ds bar.
DS bar. Yeah.
So So in the given question, F is this,
Yeah.
and let us assume R bar is equal to xi cap plus yj cap.
Okay.
We will simplify this.
Lakshman,
Yeah?
can I know the reason why you have assumed R in such a way? Like, is that a general assumption or?
No, actually we took the center as the origin.
Okay.
So generally we can take R bar is equal as taking this as a coordinate plane.
Okay.
We can take R bar is equal to xi cap plus yj cap.
Okay.
So F bar is equal to, we will be taking x square by y square whole power of 3 by 2 common.
Okay.
X square plus y square whole power of 3 by 2 common.
Okay.
And this is as xi cap plus yj
J
cap.
cap.
So as we assumed xi cap plus yj cap is equal to
Huh?
R bar.
Huh?
So in the next step we can simplify this as F bar is
Okay.
equal to k by
Yeah.
x square plus y square whole power of 3 by 2
Yeah.
into R,
R bar, okay.
By this what we will be getting is F bar is aligned to the F bar is aligned in a way such that it is always towards the R bar.
Yeah. Yeah.
So and also we can from here actually modulus of R bar is equal to x square plus y square under root according to like in coordinate geometry general we will be getting this.
Yeah.
So this will be equal to k by R cube into R,
R
bar.
bar. Yeah.
And from the above when we are explaining the question we got R bar is always perpendicular to ds bar.
Yeah.
So from the basic equation of work what we will be getting is integral f bar dot ds bar,
DS bar
and f bar is k by R cube
into R bar.
to R bar dot
DS
ds
bar.
bar. This is the scalar product.
Yeah.
So this we can write as k by R cube into R bar into ds bar.
So okay. So what you want to say is R bar and DS bar are always
are
perpendicular.
always perpendicular. So as this is a scalar product we will be
Yeah.
getting R into S into cos theta.
Yeah.
So as always the angle between the
Yeah.
R bar and ds bar is 90 degrees.
Yeah.
We will be getting cos 90 degrees is equal to
Zero.
0.
Yeah.
So work done will be equal to
Okay.
work done by the particle will always be equal to 0.
Yeah.
So basically all these sort of questions we should look into the how force vector and ds bar are aligned in
Yeah.
this problem. Basically in this problem this is perpendicular, so work done by the
Okay.
particle will be 0 and the
Okay.
option is D.
Okay.
Yeah.
So students, we have learnt a very good technique and a new simple technique to solve the problems based on work, and it's like we have got force in terms of R, and since R and DS are always perpendicular, the work done is 0. And these kind of techniques are very problem dependent, so we suggest you to identify these kind of techniques in the given problem.
Okay students, let's move on to the third question in the work power energy chapter. The third question says, one end of a spring of normal length h and spring constant k is fixed at the ground, and the other end is fitted with a smooth ring of mass m which is allowed to slide on a horizontal rod fixed at a height h. Initially the spring makes an angle of 37 degrees with the vertical when the system is released from rest. Find the speed of the ring when the spring becomes vertical. Now, can you please explain us how this question can be solved?
Yeah, Krishna, hi.
Yeah.
Actually in the given question initially the spring is at in B position and afterwards it has moved to the A position. When it is at the B position its velocity is 0.
Yeah.
Its velocity is 0. Now what we need to do is by conservation of energy, first we will be equating the energies at both positions. Let
Okay.
us see what's the energy at position B.
Okay. So So you're writing
Position B.
energy at point B.
Yes,
Okay.
at point B. We'll check what is the distance from what is the elongation in the spring. Let us take this point as O. We know OA is equal to height h, and in triangle OAB, cos 37 degrees is equal to AO by OB. That is equal to OB is equal to 5 by 4 AO, that is
Okay.
equal to 5 by 4 H.
H.
So what the elongation in the present situation is 5 by 4 H minus H is the elongation, that is equal to H by 4. So now the spring is only having the potential energy and it is not having any kinetic energy.
Okay.
So now what the energy possessed by the system at position B is half k x square, that is equal to half into k into h by 4 into h by 4. So let us name this equation as 1. Now consider the energy system at energies at position B of the
Okay.
system. At position A, in this position the spring is having no elongation, so its
Okay.
potential energy is 0, and the kinetic energy of the ring will be equal to half mv square. Let us take the velocity at position A is equal to v,
Okay.
that is equal to energy at position A is equal to half k x square plus half mv square.
Okay.
As the elongation is 0, this part will become 0.
Okay.
So energy at position A will be equal to half mv square. By conservation of energy,
Okay.
energy at position A is equal to energy at position B, that will be equal to half mv square is equal to half k into h by 4 into h by 4.
Okay.
So from this we will be getting the velocity is equal to under root of k by 16 m into h. This
Okay.
will be equal to h by 4 under root k by m. So in this way, by conservation of energy theorem, we will be getting velocity of the particle mass is equal to h by 4 under root k by m. Yeah.
Yeah. I think now we have solved the question. I think students, from this question, what you need to learn is that you don't need to worry after seeing the question how to solve it. But you can see how Lakshman has solved it. He has used formulas from simple harmonic motion to equate the energy at point A and point B, and he has solved it through using the formula of potential energy is equals to half k x square at the extreme position, which you'll get in the simple harmonic motion. Okay. Now students, let's move on to the fourth question. The fourth question says a chain of length L 80 centimeters and mass 2 kgs hanging from the end of a plane so that the length of the vertical segment is 50 centimeters as shown. The other end of the chain is fixed by a nail. At a certain instant, the nail is pulled out. What is the velocity of the chain at the moment it completely slides off the plane? Now Lakshman, can you please tell us how to solve these kind of questions?
Yeah, Krishna. Actually, in this sort of questions, what we consider is, let us take this as the zero potential energy level of the system.
Okay.
Actually, this is a table, so we are just considering this as the zero potential energy level of the system. As the part of the chain is hanging below this level, what this part of the chain will be having is negative potential energy. Here it is given a linear density chain, so we'll have the mass of the chain that is hanging of length L naught.
Okay.
Let us first assume ki total mass of the chain is m, mass is equal to m, and length is equal to l. So
Okay.
the linear density will be equal to
M by L.
linear density is equal to m by l.
Okay.
So the mass of the part of the chain which is hanging will be equal to let us say mass hanging is equal to linear density into part of the chain hanging. So this will be equal to m l naught by l.
Okay.
So in this sort of questions, what we actually do for finding potential energy is we take the center of mass of the part of the chain hanging. So the center of mass will be here somewhere of L by 2,
Okay.
but as we are taking this level as the zero potential energy, so this will be equal to minus L naught by 2, like taking this as the coordinates in coordinate geometry.
Okay.
So potential energy, initial potential energy of the system will be equal to mass into g into height. Here mass of the hanging part is m l naught by l into g into height is l naught by 2, because we will be considering the hanging part of the body.
Okay. You're considering the height of the center of mass here.
Yes, we consider the height of the center of mass.
Okay.
So the kinetic energy of the initial system is equal to 0, because initially it is fitted,
Okay.
and then at the final position it is set loose. So let us go for the final position. In final position, let us assume the velocity when it is just falling is equal to v, and at the final position body will be in this situation. Total length will be below the zero potential energy. So the total length of the body is L, and the center of mass will be at L by 2. At L by 2. So the final potential energy of the body is mass into g into h. Here mass is total mass of the body, so it will be m itself, m into g into, and h is L by 2. This is equal to mg L by 2. And as we consider the kinetic and as we consider the velocity of the body is v, the final kinetic energy will be equal to half mv square.
Okay.
So according to conservation of energy, we have initial energies is equal to final energies. According to conservation of energy, initial energies is equal to final energies.
Okay.
So in this situation we actually got initial potential energy is equal to 0 minus actually in the above, when we are considering the initial potential energy, as this is below zero level, so we will be getting a minus here, that is equal to minus m l naught square by l by 2l.
Okay.
So at the final position what we will be getting is m l naught square g by 2l is
Okay.
equal to half
MV square.
mv square minus mg l by 2. As this is considered below the zero potential energy, here also we will be getting a minus. And finally this will be equal to, when we just simplify this, we will be getting v is equal to under root of g by l into l square minus l naught square. As we are having the values of l is equal to 80, l naught is equal to 50, g is equal to 10, we will
Okay.
be getting final velocity is equal to 2.23 meter per second.
So, yeah, students, he has solved these questions by taking the center of mass of the chain which is hanging below the level as a negative potential energy